So bearings is an important application of trigonometry, and it's quite nice, I think. So let's start with, what are bearings? We've got our arrow facing here, and this is what we refer to as 0 degrees true, or true north. We know that east is going to be this way, so right, never eat, and then south down here, and we've got west. So east is 90 degrees. Okay, so we'd say that's 90 degrees true. South, it's another 90 degrees, so that becomes 180 degrees true, and you can see the pattern going on. So we get 270 degrees true, and then we're back again to 360 right at the top. Okay, so this is allowing me to tell people where to go. So if I said, off you go, can you please head off at 160 degrees true? Then we're going around, and we're going here. Okay, so that all the way around would be 160 degrees true. Equally, if I now went for, let's go 280 degrees true, then we go all the way around, just past 270, and huzzah, that will be your 280. So that's one of the things that we're going to use in our applications. The other property to complete these questions, or to help you complete these questions, we need to understand or remember the property of parallel lines. So if I've got two lines here, the arrows indicate they're parallel. If I have another line that crosses it, I hope you remember something about the two angles inside these parallel lines. Right? They have to add up to be 180 degrees. I refer to those as allied angles. Your teacher might have called them co-interior. I call them, as we said, allied or co-interior. Okay, so where do we apply these to our bearings questions? You'll see in a minute, but really we have our true north here. We're going to have two lots of those, and of course we'll be able to say that, let's say if this angle becomes, if we say that's 110 degrees, then that would mean this angle would have to be 70. Okay, 180, take 110 gives you 70. So let's actually put this into practice, and let's look at a typical question. Okay, we've got Daffy Duck flying around, and he's going to go 15 kilometers in the direction of 165 degrees true. He then stops, changes direction to go 85 for 6 kilometers, and we want to find the distance and bearing from his starting point. So all of these questions, we start by, let's just put a dot somewhere there in our page, and we put our dotted line now, which indicates our true north. So we're going to fly 15 kilometers in the direction of 165. So let's have a look. So we remember 90 degrees would be coming straight out here. We don't want that. And 180 degrees would be down here. So we want 165. So we're happy that that would be somewhere like so. So we draw that. We pop in that that is 165. Right? Always put your information in. We label that that is 15 kilometers long. We've done a good job there. So the next thing, we look at the next instruction, and that is we're going 6 kilometers now at 85 degrees. So once again, we pop the degrees true. Okay, I would also actually go back, and I like to put the direction. So this is my starting point, and we know that we're heading that way. You could put another arrow in the middle if you really wanted to show that it's going that way. All right, so now we have to go 85 degrees. So remember, 90 degrees would be going that way, so we'd like to go just a little bit above that. Okay, we are also trying to give a reasonable drawing. It doesn't have to be exact. So for 6 degrees, we're not going to go, sorry, 6 degrees, for 6 kilometers, we're not going to go a massive line like that. If our 15 was here, obviously it's going to be in proportion to that. So you're happy? Oh, that's not very good. We'll go from here, and we're going to go right, and that is 6 kilometers. And don't forget, pop your angle in. That was 85. Your job is, we would like you to find, well, the question wants you to find this length, right? And we want the bearing all the way to the black line there. And you might think, isn't that 165? This is where you've got to have a really sharp pencil and your diagram has to be nice. The 165 actually goes all the way to the pink line. So what we're going to want to try and do is find this angle. And once we find that angle, we can take it off from 165. The problem is we don't have enough information thus far. So we can see we've got these two lengths here, the 6 and the 15, but unfortunately I don't have this whole angle in the middle, because if I did, I could use the cosine rule, right? Because I've got two lengths, angle in the middle, that's cosine rule. So how can I find this angle here? I can do it without using trig. Now remember, we talked about our parallel line properties, that the angles inside your parallel lines have to add up to be 180. So you can see our blue line here is parallel to this one, and the pink line crosses. So all the way there, that we're saying is 165, which means this angle here is 180, take 165, so that's 15 degrees. 60, 70, 80, correct. So that makes that 15 degrees. If you think that that's, crazy looking at that diagram, imagine if you just popped in the information that you had, right? We've got this is 15, we've got this is 6, this whole angle is 100 degrees, and I'm asking you, or the question is asking you to find x. You've done these questions over and over again. So that's our simple cosine rule, because you've got the two lengths, angle in the middle. So where we go, we're going to go x squared equals 15 squared plus 6 squared, 2 times the two lengths times cos of our angle. All right. So pop that into our calculator and we make sure that we square root our answer. So you go off and do that. Right, so we should have got 17.1. Check your calculator. If you didn't get that, did you square root? Did you press cos? So make sure you've done that. So that gives me here 17. In fact, I'm going to erase all of that. I'm going to pop in 17.1 because we now have that length. Now remember what we wanted. We've got the distance. We now want the bearing. So that's this angle here, which relates to our triangle here. Okay? And now, we've got 3 lengths, so you could use the cosine rule going backwards. But that's a lot of work. What I'm going to prefer to do is go, well, I've got a known pair. Oops. Why did that not work there? I've got a known pair. It wants to stay in black. And this is my angle here, and I know it's opposite length. So I'm going to use the sine rule. Okay? So it's going to be sine theta over its opposite length, which is 6, equals sine 100 its opposite length, which is 17.1. And now we just have to get theta by itself. So to get rid of the divide by 6, we're going to multiply. And to get rid of the sine, we're going to inverse sine. So we should have been pretty comfortable with this. If you're not, go back and look at some of the videos for the sine rule. So pop that into your calculator and you should have got 20.2. So now go back to your diagram. That's what we're saying this angle here is, 20.2. And we want that bearing here. So hopefully you can see from your diagram it's going to be 165 minus the answer you just got of 20.2. Okay, and that's going to equal 144.8 degrees true. And we're done. So we've got our distance and we've got our bearing.